Hi there. Today I will demonstrate about the functional programming principles and the design patterns. And these documents provide the five functional programming principles, and they are with the examples and counterexamples. They are pure functions, immutability, first-class function, high-order function, and declarative over imperative. Also, there are three array functional programming method in use of the map, filter, and reduce. Also, there are three examples of design patterns in the singleton, module, and factory. And we have the explanations about why they are good application of functional programming and of the examples and the counterexamples that break each concept. We also have the supporting code of the example of each principles and the example of the why they are break the concept. Okay. Okay, for the first is a pure function. Uh, this example is from the story list.jsx. We can say that this function is a pure function because it didn't have the a side effect. It didn't change the external variables or the global variables. And this function takes in the progress and story IDs, just like there and there. And it always returns the same count without side effects. For the counterexample, it breaks the concept because for this line of the code, it's mutated the external variables because it have the let total equal to 0 and they change the number of total. The second is immutability. For this one, it's an example of the app.jsx. For the new path is create a new array, and for there is copy the existing progress to avoid mutating the original array. Um, yes, for the immutability is use a spread operator to create a new object and a new arrays instead of directly modifying the existing progress and the path and ensure the data is immutable. And for the counterexample, um, for this one, it's the directed mutations. So why this break the immutability? Because it directly modifying the existing object or array, and it's lead to hiding the some of the side effects, and it's making the code harder to debug and maintain. And thirdly, the first class function. It's out from the app.jsx. And for this one, function handle choice and handle restart I passed as a prompt to the game screen. And in JavaScript, the function can be treated like the any other values assigned to the variables, passed as arguments, or return from the other functions. And but for the counter example, for this one, it's hard-coded event logic. So by hard coding the logic inside the game screen, you lose the flexibility of the injecting different functions, and it's less uh, testable and maintain, and it's hard to maintain. And for fourth one is high order functions. It is from the store list.jsx, and we use the map. And the map is a high order functions. It takes a function that as an argument and returns a new array. This is more declarative and uh, more direct declarative than the manual loop. So for the counterexample, it breaks the concept because it has imperative loops often the involve the manual index management, and it's a mutation of the array and making the codes more error. And the fifth is a declarative or imperative. This is a very interesting one. And this is from the game screen.jsx. And because we use the JSX is used to declaratively describe the how the UI uh, should be rendered based on the state changes without the manually on the do. So, but for the counterexample, is change the do manually. Its declarative change the do elements is in the imperative, and you specify the how to update the UI rather than what the UI should be in response to state. And for the second part is the functional array method in use. So we have the map, filter, and reduce. And for the first one, it's an example of the from the stories.jsx, and it's transform each story in the JSX element and providing the ex, express expressive way to render the list like this. But for the counterexample, uh, it didn't use the mapped array. It's just use the loop and its imperative approach for the for this event for this function. So uh, it's it breaks the concept of the map. So it didn't use the map to uh, do some function. And for the filter, it is the same because it's also from the story.list.jsx. It returns a new array contains only those stories meeting the condition, improving reliability, and reducing the manual looping. For the counterexample, is also imperative approach because using loop to the filter stories like this. You create a variable externally and use a for loop. And for the reduce, it's from the a app.jsx, and we'll use reduce to some of the other discovered engines. But for the counterexample, it is an imperative approach using the for loop for the aggregation. For this, like this one, you created an external and change the external variables like using the for loop. So it's break the concept. Okay, for third part is the design patterns in code. So we use three patterns. The first is signature, and the module, and the factory. For the first one, signature. And when we use the signature, we should ensure only one first instance and no share the multiple state across the modules. And it prevents the mutable or conflicting connections because we just use the only one first instance. And for the counterexample, for this one, the second is cause conflicting instance. And for the second is module pattern. And each for this one, each component is in its own file and acting as a as a module that exports as a single responsibility, and it is to keep the code organized and maintainable. But for the counter example, all the all the components are defined in a single file and is leading to tight coupled code that hard to maintain because it's highly coupled. Because if we write a code like the game screen story list, a tutorial, and another components, all of them in the function app, it can cause the highly coupled and it's very hard to maintain. So it's break the concept. For the last one is the factory pattern. Mm, for this one, it encapsulates the logic for the creating nodes uh, object in the one place, ensuring consistency. For example, it automatically sets its ending if there are no choice, and it manually and for the counter example, it's manually creating a nodes object in the different places. And this is a one, two, three. So why the factory is better? Because if you need to change how a node is structured, you only update a factory rather than the every location that create nodes like this. This is a bad example because you you change all the location of the creating nodes instead of using the factory part. So why there are good application of the functional programming? First one is the it's a predictable state update. Its immutability and the pure functions make the states change more clearly and reducing the bugs. And the second is improve the readability. How the function like the map, filters, and views are more expressive and the yes is more expressive than the imperative loops. A third is I think is flexible and composable codes because the first class function allows you to pass the callback around, making your components more reusable. And for this one, I think uh, that is for the demonstrating. We covered key functional program principles, design patterns, and how they improve the development experience in React apps. Okay, thank you for reading through the my functional programming principles markdown file, and thanks for watching our videos. Thank you.